My name's Ian. I've been teaching mathematics now for 18 years in total, the last 8 years in international schools here in Korea. I'm going to talk to you today about concept-based approaches to teaching mathematics with a specific focus on inquiry into trigonometric functions, transformations and gradient functions. So focusing on something called the conceptual lens and how we use that in our teaching to bring out certain thought processes and development within the student. In this first section, we will talk about the philosophy and focus. Teachers hold a particular role and responsibility within the classroom, and it's very important for us to understand what that role is. For too many years, teachers have been in the position of being seen as the expert, just imparting their knowledge, their understanding into students' minds and thoughts, and students have been perceived as being empty vessels, not having the understanding, so they need to receive it from the teachers. This is a kind of old-fashioned way of looking at teaching, and nowadays we've tried to be more holistic in our approach to teaching, and international schools in particular provide an excellent opportunity for teaching and teachers to develop their style, to nurture this within in the school system. John Dewey was a good proponent of this. He talked very deeply about the philosophy of education and about what it is to learn. As an example, Einstein was a very clever man, a genius in his own right. He taught us many things to do with physics and so on, but when he was at school, he did not have an easy time. From his teacher's perspective, he was rather an annoying student. He was always asking questions and always asking intelligent questions, which was quite threatening to teachers. He was seen as being rebellious and he was seen as being arrogant. The teacher's perceptions were, let's learn facts. So students, please sit in your seats and learn the facts. From Einstein's perspective, he was just interested in the subject, interested in the learning matter. He was very inquisitive by nature. He was always searching for solutions. Therefore, he was always pestering the teacher for help. He also wanted empowerment. He wanted to have a decision in his education, and he was fighting to seek that. But unfortunately, the school system he was in did not accept that very easily. A recent author, Joe Bowler, talks very in detail about mathematics and how students best learn mathematics in the classroom. Joe Bowler, the type of teacher Joe Bowler talks about, is going to be significantly different from the type of teacher that Einstein experienced in his school life. Joe Bowler talks a lot about conceptual learning and about the mindsets that students have. And it's the role of the teacher to develop mindset within students, to encourage students to develop and grow as learners themselves, and to provide them a framework within which to understand the mathematics, in this case, conceptually. What we want really is for teachers to get unstuck from the whiteboard. We don't want teachers to be stuck at the front of the classroom just delivering instructions and explaining stuff to students. We want students to be engaged in the learning. So we're looking for a classroom where the focus is not on the teacher, the focus is on the learning. We need to be able to shift this focus away from teachers' character and personality and onto the subject matter, onto what the students are learning. This will empower students and give them access to their learning and give them some ownership of their learning. The teacher's still there to support them and help them, but we want to see students who are growing in this way. It's going to result in better learning, and it's going to result in better learning that sticks longer in the minds of the students. On the other side, Joe Bowler also talks about mindsets. Especially in mathematics, mistakes can be seen as being necessarily problems, but they're actually necessary learning steps in the process. Students, we need to guide them to think about their own learning and to evaluate their own learning so that they can see what mistakes they've made, build upon their mistakes, and then develop as learners themselves. Inquiry will enable this. So if we have a lesson that is focused on inquiry, students have the opportunities to develop all of these skills. Whereas if we have a lesson where the student is focused on the teacher and listening to the explanation, then it cuts out the opportunities for that student to develop some of the things that are mentioned on this board. Ron Pritchard talks about creating opportunities for students to learn, opportunities for them to engage in the lesson, opportunities for them to be challenged in their misunderstandings, to develop their understanding to a deeper level. So we'll move on to the next part of this session, which is talking about planning the unit. With those philosophy ideas in mind and with those ideals in mind, we need to think about what we do as staff to try and make these things happen as teachers in the department. For this talk, I'm focused on a grade 11 class. They are learning the DP standard level course. There are actually 3 classes with 3 teachers. I teach one of the classes, 2 other teachers teach the other class. And they have recently done work on trigonometric functions, the concept of functions, and some other related ideas and concepts, which come into the task I'm going to talk about using an example later. So what we have on the screen is an overview of this unit. This is the result of our planning process. It's called a unit web. It can be found in books on concept-based mathematics learning, which are being published recently and currently. And it just summarises what the unit is about. It splits it into knowledge strands. Within each knowledge strand you have micro and key concepts, the key things that the students will try to learn. So it's very focused on those concepts. And also you have generalizations, which take those concepts and build them into broader things that the students can use in terms of what do they understand, what do they know, how can they extend their learning from this point on. Now the planning process takes a long time and takes up some time in the working week. It requires teachers meeting together, working collaboratively and organising the unit. Starting from a unit title, which might just be an idea of what we have to teach in the coming 3 or 4 weeks, you then have to work through this whole cycle of developing a unit, looking at the topics, the knowledge that's incorporated, looking particularly at the concepts that you are trying to get across to the students, and picking out key things like guiding questions and the common assessment that's going to take place at the end, in order to ensure that the unit will hold together as a whole piece of work, but that the students will have been supported in their learning process and have developed their conceptual understanding throughout the unit. On the end here in the different colour is also what takes place after the unit's happened. Okay, we need to give some time over to meeting together as teachers and assessing how well did the unit go. Firstly, how well did the students learn? But then also, how can we make improvements for the next time we use the unit? So this type of process, this cycle, takes place in the diploma programme, but it also takes place elsewhere in the school. And whichever international school you're in, you'll probably find these cycles happening in collaborative planning. This slide shows an example of the inquiry that's being set forth for this particular unit. Okay, so there are three broad areas within this. What we want the students to know, what we would like the students to understand, and what we would like the students to do. Now for knowledge, it's easy. We know what we want the students to know. We know that we want them to know about trigonometric functions, for example. It's easy to say what we want students to do. We want them to be able to take a sine graph and transform it, for example. The challenge is, what do we want the students to understand conceptually? That points to a deeper understanding of the topic. So this middle section, as you will see on the next slides, becomes the focus of our planning. In the unit web, there were generalizations. Each of these generalizations is focused on that conceptual understanding. So the next part of the module plan has these generalizations within it. Beside each one, there are some guiding questions. These questions enable the teacher, whoever the teacher is, to guide the learning that's taking place so that its focus remains on the conceptual ideas within the topic. So for example, the first one there is talking about connecting trigonometric graphs to data collected from real-life sources. And there are some guiding questions. Factual questions are knowledge-based. What is periodic data? What is time series data? But there's also a conceptual question. Why does periodic data occur in nature? Why does it happen? So factual questions are like what questions, conceptual questions are why. They're probing for deeper understanding. Each generalization, and in this unit there's about 9, has in total 3 or 4 factual and conceptual questions. The entire unit has 2 or 3 debatable questions. These are questions to try and provoke the students to think a bit beyond the topic, to raise questions, to challenge their own understanding. Is this always true? Is this always the case? Is my knowledge always applicable in this situation? What about in this situation? The structure you see here as well also has incorporated some of the diploma program specific things that you might read about if you go onto the IBO website. Things like approaches to learning. Once we have the unit plan, you would then put together the unit web, so you've got an overview of the unit, and then you could start thinking about, well, what are we going to do in the classrooms this week, next week, and the following week? The example that I'm going to use today with trigonometric functions is actually the 3rd week of the unit. So the first 2 weeks we've been looking at the earlier foundational concepts. What is a trigonometric function? How do we transform functions? But in the 3rd week, we're looking at how do we take that understanding and apply it to something less familiar for the student. How do we take that knowledge that the students have developed and use it to develop a knowledge that connects to a wider spectrum of mathematics and also links in with a harder topic which is covered actually later in this year in grade 11. Section 3, I'm going to talk to you about the conceptual lens. All of this process is to put in place a series of lessons to help the students gain in knowledge, but mainly to gain in conceptual understanding. The conceptual lens is one focal point that we use to help ensure that for every lesson we can bring back the students to this same focus. It kind of combines and ties together the topic. Is the conceptual lens. We're focusing on the conceptual lens because this is the thing that allows us to build connections, to build synergy with between the thinking and the ideas that the students are experiencing over the course of the entire unit. Throughout the lessons that the students are taking part in, engaging in, they're going to have a number of ideas. They're going to experience a number of ideas and have some ideas themselves. So looking at the topic through the conceptual lens and creating opportunities to do that will help the students to build the right connections and to build the right understanding between those ideas. Relationship is the one we're using for this unit, for trigonometry. There are others available, and in mathematics, these are the ones which could also be used: randomness, patterns, systems, form. These are all examples of conceptual lenses. They are large, big idea concepts. Okay, they are things which can be used to combine and merge a topic. The conceptual lens is not always a natural thing for teachers to focus on. Teachers find it very normal to focus on the topic they're teaching and what's the next bit of understanding that they want to get the students to achieve. So we need mechanisms to help us to focus on the conceptual understanding and ensure that the synergy and the connections are made. Recently there's been some very good resources from Visible Thinking, one of the universities in Canada, I believe, and they have lots of strategies which we can use as teachers in the classroom to focus on conceptual understanding, to use as a mechanism for developing the use of conceptual lens and focusing on, in our case, relationship in the classroom. The one that I'm going to use in this unit is called Connect Extend Challenge. It's quite an easy one to understand. It's about taking prior knowledge and then extending it into current knowledge and applications and understanding, and then developing that further by challenging the students' understanding. But there are many others. So in this first section, we've talked about these three things: the philosophy and focus, which is the philosophy and focus really of the teacher. How does the teacher view themselves? What's their role in the classroom? And is it focused on being a personality, being the person leading the lesson from the front? Or is it being the person that's leading learning and doing everything they can to help the students develop their conceptual and knowledge-based learning through whatever mechanism that might take? We've also had a brief overview of the planning of a unit, what steps we need to take as staff to collaboratively plan and decide on how we're going to make the unit flow. And then just now we just talked about the conceptual lens, a tool that we use in order to help the students build synergy and connections between the knowledge, the facts, but the concepts and the understanding that they're developing in the topic. Thank you.